All right, we're going to do 121 through 124. And it's about these light bulbs burning out, and so I've typed into list 3 all of those many numbers, and there's 60 of them. And it says for 121, so for 121 I don't have to do anything except say describe in words what the population mean mu would represent. And it would represent the average time for a bulb, light bulb, to burn out. How long it lasts before it burns out. Okay, now we can take, and I can do stat, calculate the one variable statistics on my list 3 where I put all those in there, and I get a sample mean to be a 602.87 hours, about 603 hours. But that's for this sample. What's the population? And so now I'm going to go to 122 and say, well, at a 95% confidence interval, so I'm 95% sure that it will fall between what two numbers? Well, that's when you do two standard deviations, and we only have the sample standard deviation. Let's get that down. See, from the calculator it says the sample standard deviation is 103.57, 104. And I'm going to just round this off to 603. So I would take 2 of those. So I'm going to take 2 times 104 divided by the square root of how many there were, and there were 60 of them. So I'm going to get the standard deviation, or the standard error, which is going to be 2 times 104 is 208, divided by the square root of 60. And so I'm going to get a standard error of 27, approximately 26.85, 27. So I'm 95% sure that it would be within 27 of 603. So I'd have to subtract 27, and that would be 603 minus 27 is 576. And the population mean is somewhere between that and 603 plus 27, which is 630. 95% sure that it's between those two numbers. Then they said do a 90% for 123. And so instead of 2s, we use a 90%. We use not 2 standard deviations, but 1.645. So I would do this calculation with 1.645, which, and I'm going to round a little bit off of that, so I'm going to be 1.65. 1.65 times 104 divided by the square root of 60, and I get 22. So I'm going to go 603 plus or minus 22. So if I take away 22, I will have 581. Would be smaller than the mean, which is smaller than, and then if I add 22, I get 625. I'm 90% sure that it's in here. Notice this is a little bit narrower, so it's less likely to hold the mean. So that's why it's only 90%. 95 is wider. So I'm narrowing in on what the mean would be, but I'm less and less sure that it's in there. And if I did a 68% confidence interval, I'd be multiplying by 68%, which would be one standard deviation. So I just do a 1/0 for 124. I would use 1 standard deviation gets 60% of 104 divided by the square root of 60, and that's how much I would add or subtract from the mean 603. 104 and that's 13.4. So I'd have 603 plus or minus 13, which is 590, which is narrower than before, up to 13 more would be 616. And this is a much narrower, so we think it's closer to in here, but we're less sure. It's only 68% sure, or confidence level, that it's in that interval. So that was 121 through to 124.